Hello and welcome to a new video, this time about do-it-yourself arcade cabinet spinner. Arcade cabinet spinners are input controls that once were used for arcade cabinets for specific games. One example or several examples that you might have heard of are Tempest or also Breakout. I think both were from Atari. And spinner is basically a kind of knob, like you see here in this example, that can be turned in the one or the other direction, and by doing so it provides input to the software. And yeah, you can imagine this as a kind of one-dimensional mouse. It works relatively similar to one of the early mechanical mouses in the way that you have at the bottom some kind of flywheel and encoder wheel, and by turning the knob there is some optical sensors that recognize the motion and transfer it into electronic signals information that can be processed by the software, specifically by the game. I designed one of my own as I was not able to find one that fits my needs. They are not very common these days, nevertheless they are available on some specific online stores. However, they are a little bit pricey. I found some about 80 to 90 euros, something like that. But another fact was that I hardly looked for some arcade cabinet spinner that is capable of have some illumination, like you see here. I like to have a spinner that modifies its color, its lighting, depending on some logic. In this particular case, you can see if I turn the knob, the color of the light will change from blue over pink to glowing red. And for doing so, the spinner needs to have some transparent components, like in this example. Well, as I was unable to find a spinner that fits my needs, I decided to build one of my own, and I share all the plans and files that are necessary on the Thingiverse page. I put the link down below to this video, so if you're interested to rebuild one of your own, you can follow those instructions. And surprisingly, the components that are necessary to build such a device are not very expensive at all. Basically, it's all the stuff that you see lying here around on the desk. It's most of all a couple of 3D printed parts, these 6 parts here. The material costs for them are not very much. It's about 60 grams of printing material, which is approximately 2 euros or something like that. We need, of course, some kind of ball bearing to make sure that the knob can spin very freely. But without being too shaky and wacky. We of course need these optical sensors. We need 2 of them, otherwise we wouldn't be capable to recognize the direction that we spin, and it's quite important for playing the game, so the game knows whether we turn the knob clockwise or counterclockwise. If we want to go with some illumination, of course we need some LEDs. The 3D printed shapes that I'm using here allow to install up to 5 LEDs in standard 5mm housing. I decided to go with particularly so-called neopixels. They have some very nice features. One of them is that you can directly address them, give them a specific color, and electronic wise it's only necessary to have one I/O pin or one I/O port on the processor to address those. With RGB LED, for example, you need more than one, you need at least 3. Furthermore, we need some kind of microcontroller to control all that stuff. What we use here is a so-called Arduino Pro Micro. It is, from my point of view, absolutely perfect for that purpose, as it is very small. It has capabilities to act as an USB mouse. Once it is programmed, it will be automatically recognized by each operating system that supports USB mouse. has a couple of I/O ports that we need to attach the electronics that we need, and it's not very pricey. It's approximately between 3 or 4 euros if you look for the different sources. I went to AliExpress, I saw them for 2 euros 80 cents, something like this. Yeah, of course we need also a couple of screws to screw all the things together. All together, all the parts and pieces you see lying here around are not very much more than 10 euros or so. Before we go to the details of the mechanical setup, we should have a look on the electronics first, because they get installed on the mechanical parts, on the 3D printed parts, and therefore they need to prepare first. What I already done ahead of time is I prepared those optical sensors that you see here. If they are new to you, they basically consists internally of an LED on the one side and a phototransistor on the other side. And the way it works is that once it's installed, when something goes in between the LED and the phototransistor recognizes the interruption of light and gives an electronic signal. And this is what we use together with such an encoder wheel. Once it is installed, the encoder wheel gets turned between those LED and phototransistor, and by doing so the interruptions get counted and will be translated into information that is passed over the USB port and gives the software the information it needs to make the game move. To have those both installed a little bit easier, once they are attached to some wires, they will be installed in the bottom side of this 3D printed part. There are two shapes, holes, where they exactly fit in. They just get in like that by press fit. Of course we can add some hot glue to make sure that they don't escape. What I did ahead was that I prepared some by soldering some wire. I used this flat ribbon cable with 3 wires and solder them to the bottom of these optical sensors. Both the phototransistor and the LED that is internal have a ground, so I joined both grounds together, and that leaves us with another wire for the voltage that drives the LED and for the signal line that feeds back the information, so that we end up with 3 wires. And at the other side of the wire I attached some pinnate connector for ease of installation. As already said, we need 2 of them, so I prepared 2 of them with soldering wires and adding connectors to the end. And once we have them available, we already can install them into the mechanical shape, this plastic piece. I just put it in, push it all down to the bottom. The other one the same way. Exactly like this. And as you can see, there are some channels in the back side where these cables can run along, and when we install the microcontroller on the back, we don't do this directly. Of course we can directly solder all the contacts from the sensors directly to the arduino and hot glue in at the back, but I like to have things easily assembled and disassembled, and therefore I go with so-called shield, which basically makes it a little bit easier to do all the wiring. And this shield, once it is soldered, can be screwed with a couple of and 3 screws to the back of this device. How this shield should be designed, or I have some proposal for that. I can give you a short overview. One common way to attach electronics in an easy and comfortable way to an Arduino microcontroller is what is called a shield. It's basically some kind of PCB. In our particular case, it's sufficient to get it hand wired. And this PCB will provide some pinhead connectors where all the things will be just put in. We start with 2 rows of pinhead connectors for the Arduino itself. It's along that line and along that line here below. And some more pinhead connectors where we connect all the sensors, some LEDs, and that also allows us for some configuration. The first thing we want to connect are the sensors for the spinner itself. And the sensors that we need to use, and as I already explained, we need to have 2 sensors for one single spinner or pedal, as this is necessary to recognize the direction, clockwise or counterclockwise. And one of these sensors that goes by the name ITR9608, each of them consists basically of 2 internal components. The one is an LED that emits light, and the other one is a phototransistor that recognizes whether it receives the light or not. So when something interrupts the light beam, the signal gets recognized, and there's an electronic signal that can be evaluated and translated into information that we use to control our software. Well, the internal LED of the optical sensor needs, of course, some power, some voltage. Unfortunately, the voltage is a different level than the level of the Arduino. Arduino has a 5 volt here on that pin. That 5 volt needs to get connected to a 180 ohm resistor to get the right voltage for the internal LED of the ITR9608 optical sensor. So that's basically the pin on the lower row in this illustration. The middle row is where the ground is connected to, and finally we receive some signal from the photoresistor that signals whether the light beam has been interrupted or not, and this is the most upper row here, and of course that needs to get connected to different I/O pins. So to sum this up, the pedal E sensor 1 gets connected to this row, or pinheads connector row, with the reduced voltage down below, the ground in the middle, and the signal up. And this is connected to the I/O pin TX0. The sensor 2 gets connected in the same way, but to RX1 I/O pin. And if we want to have a second spinner controlled by this assembly, then we can do so by attaching it the same way, but to I/O pins 2 and 3. Again, the same, connected to I/O pins, to the ground, and to reduce voltage by using some 180 ohm resistors. And as we have 2 spinners attached, we have the possibility to configure them as 2 different axes, either x-axis or y-axis. This is where we use some more I/O pins here at that side. The I/O pin 7, when connected to ground, defines whether the spinner that is connected to TX0 and RX1 will be affect the x-axis. X-axis gets affected when I/O pin 7 gets connected to ground. If it's not connected to ground, then the spinner at TX0 and RX1 will affect the y-axis. The same is valid for I/O pin 8. I/O pin 8 will control X and Y configuration for the spinner that is connected to I/O pins 2 and 3. Just in the same way, that means when I/O pin 8 gets connected to ground, the spinner on I/O pins 2 and 3 will move the x-axis, and if it's disconnected it will move the y-axis. Last but not least, we use some more I/O pin 5, to control neopixels. Neopixels is a very nice kind of RGB LED. It just needs a single I/O pin to control not only the color of one neopixel, but basically we can have control over a number, literally hundreds of several neopixel LEDs. And another nice feature of the neopixel LEDs is that they run directly by 5 volts, so we can have these connected directly to 5 volt without any other resistor. That's about the connection and attachment of the electronics to the Arduino Pro Micro. Well, and once we have installed our optical sensors, attached the hand-wired shield, connected the Arduino and the sensors, we also might want to install some LEDs for illumination. The plastic piece has 4 holes that where 5mm LEDs fit into. As already explained, I use these kind of NeoPixel LEDs. They are also available in a 5mm housing. They fit perfectly in this hole. Of course, we want to have them soldered to some wires and some connectors for ease of installation. I already did this before. And what we basically do is that we apply them here. And what also is for ease of installation is we have here this kind of clamp-like shapes around that helps us to install the wiring. It just gets pushed inside. No. That way. And that way. And one more. Yeah. Just a quick test here. Yeah. They work fine. Well, once our electronics are installed, the illumination, the sensors, the controller, we can get connected and installed together with the rest of the mechanics inside the cabinet. I have another cabinet here. This piece of black plastic shall substitute the controller surface. It's 6mm thickness and hole by a diameter of 30mm. What we need to do is we put them on the underside of the controller panel, align the holes. Then we have this piece here, this tube-like piece with some threads on the outside. We just put it in the hole, and like a screw, we screw it in. And the last millimeters we need to make it tight so it doesn't get loose. This is where these tool piece of plastic comes in. We can use it with like a screwdriver on the back. The shape of this tool on the back side aligns with the shape of the inner side of the tube. So we can apply a little bit more power for the to tight this. It gets a very strong hold. Next thing that we do is we use our ball bearing install it here on the middle of the this tube. It gets a little bit easier if we use our knob here and slide it over the knob right down, and then we center it and push it on top. Yeah. Well, we almost done with our installation. The very last thing that we need to install is a combination of the encoder wheel together with the flywheel. We screw both together with a couple of 5mm screws and 5mm nuts, just for the purpose that these screws and nuts add some weight and mass to increase the inertia of the turning motion of the spinner. So let's start by applying them. So we add some more nuts to get some additional weight and inertia mass. The way it is designed gives you some room to play. You can add more or less depending on your taste. Well, by the way, the encoder wheel for visual reasons should be in some non-transparent colored material. Preferred would be black, but as you can see I didn't have some black material for the 3D printing. So what I did, I used what I have, it was this orange one, and just colored it with some pen in black. This also will work. Well, the last step is to move this assembly on the back side by aligning the two shafts. They should fit well in each in another. Applying it with some pressure. Make sure that the teeth of the encoder wheel will interrupt the light beam of the sensors. Yeah, now it's perfect. And last but not least, add one 3mm screw in the center of the flywheel, so that the knob at the top and the flywheel assembly will get secured to each other. Well, if this is your second spinner, you don't need to have a second microcontroller. You can, as already explained, attach the sensors and all the NeoPixel LEDs to the first one that you already have installed. I'll just show you how. Use the two connectors of the two sensors of the second spinner. Apply them to the two NT pinnate connectors. No. One and two. And for the illumination, those NeoPixel LEDs can be daisy chained, which basically means that the output of the first one provides the input for the second one, and therefore we just need to attach these two connectors. And as you can see, we have now both illuminated, but not only that. If we spin this one, you can see by the change of the illumination that the speed and motion is recognized by the Arduino, and that is also capable for the second one. Also, this changes its light and recognizes the motion. and that's the way they get attached to each other. There's one final thing that you need to know. This is how we get the firmware installed to the Arduino Micro Pro. To install the firmware on the Arduino Pro Micro, we need two things. The one thing is the firmware file itself, the other thing is some uploading utility. You can find both on the Thingiverse page of the thing. Just go there, go to the Files section, scroll down the list of files. You will find some file that goes by the name tuspin2_fw.txt. That's our firmware file. The integer within the file name, which is currently a 2, might vary over the time as it indicates the firmware version and may be different for further upgraded versions. Just download it. Then go back to the details screen of the thing, scroll down and you will find a link to Arduino Uploader. Click on that. You will come to the page where you find the uploading utility that goes by the name Arduino Builder. You will find some basic information on how to install and use this uploading utility. Just go down. You will find a download link there. Follow the download and installation instructions. Once that is installed, start the application. It looks like this. The very first thing we need to do is load the hex file that we downloaded. It contains the firmware. Click on that button here. Select the file. Now there's a first basic check of the hex file. Next thing is that we need to select the type of Arduino that we want to program. Click this list. You find a couple of different versions of the Arduino. We need to select the Arduino Micro, even if it's an Arduino Pro Micro. From the point of programming the firmware, there's a difference between the Pro Micro and the Micro. And the last thing we need to do is click on the right button that indicates the COM port where the Arduino is currently connected to. This is a little bit difficult or tricky because this might vary depending on your machine. In my particular case, it's connected to COM port 11. It might be some different port on your machine. Just click on the button. And the programming starts, and that's all you need to do. The firmware is uploaded and installed to the controller within 7 seconds. Now we can close the application, and that's all you need to do to upload the firmware. Once our spinners are assembled and the firmware is installed on the controller, they're ready to use. Just attach the controller with an USB cable to any computer and it will be recognized as some USB mouse device. I hope you found this instruction helpful and interesting. Thanks for watching. See you next time.